आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
The question is, one of the assumptions of kinetic theory of gases is that no force of attraction exists between the molecules of a gas. State and explain the evidence that shows the assumption is not applicable for real gases. Okay, so if we talk about this assumption that was given by the kinetic theory of gases, that no force of attraction exists between the molecules of a gas, is only true for ideal gases, right? It is only true for ideal gases because ideal gases have negligible forces of attraction between the molecules because it is assumed that the ideal gases have a large space and the molecules are very largely separated from each other. So there is no force of attraction that exists because the particles are far apart. The molecules are far apart and there is no force of attraction that can exist between these molecules. And the conditions for an ideal gas are actually low pressure and high temperature, right? It can exist. No force of attraction condition can exist only at low pressure and high temperature, because what actually happens is that when the pressure is low, it means that the volume is quite a lot. And when volume is quite a lot, it means that the molecules are so far apart that they cannot even interact with each other, right? And high temperature implies that the molecules are in a very high, random, rapid motion, right? And therefore, no force of attraction can exist between them, right? One reason is that the volume is quite large, and the second reason is that high temperature condition makes the molecules move faster in their position, then no interaction takes place between them. Okay, so this assumption is only true for ideal gases. So one evidence, and also ideal gases cannot be liquefied, right? They cannot be liquefied. Such gases cannot be liquefied because the conditions that they obey are not suitable for liquefaction, right? So the evidence that proves that this assumption is not true is that real gases can be liquefied, right? When they can be liquefied, they can be liquefied on cooling and compression, right? If we apply some pressure to the real gases or we cool the real gases, what happens? Liquefaction takes place. The real gases can be liquefied, whereas ideal gases cannot be liquefied. So this is one of the major distinction between real gases and ideal gases. Ideal gases cannot be liquefied because the volume is quite a lot, the molecules are far apart, there is no force of attraction, you cannot compress such gases because it is an ideal gas, right? But real gases can be compressed, they can be cooled, and hence they can be liquefied. So this is the evidence that shows that this kinetic theory law is not applicable for the real gases, right? That's all for the question.
क्लास 6 से 12 से लेके नीट, IIT, जेईई मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।